Okay, for today's lesson we're going to be looking at tree diagrams. Now, tree diagrams are a real important part of probability, so I'm actually going to split this lesson up into two parts. So, as I said, they're one of the most useful diagrams in probability, and the easiest way to explain them is by using an example. So we're going to take a coin and we're going to flip it 3 times. At the end of each one, we're going to record what the result is, and we're going to answer 2 questions. Well, first part, draw a tree diagram, and I'll show you that on the next page. And the next one is answering a question on probability, which is, what is the probability of getting 3 consecutive heads with the coin? So this is what a tree diagram looks at. So we've got our start point. Now we flip the coin. On flipping the coin, we can have 2 possible outcomes, either a head or a tail. And each of the probability of each of those is actually 1/2 each. We then flip the coin again. Okay, so we're now on our second throw. From the head, we can either go and get a head or a tail again. And again, each of these has got a probability of 1/2. Or if we've got a tail, again we can get a head or a tail. Okay, when we get to the third throw, we're in the same position. Each result from the second throw can result in either a head or a tail. Now this is what a tree diagram looks like. To be honest, they don't get much more complicated than this. And this is probably the maximum you'd have. Occasionally you might have 3 or 4 coming off it from the initial one, but then you'd only ever be looking at the first and then maybe a second one. You wouldn't be going on too long, because otherwise it just gets all crowded up on your page. One of the things to note about a probability tree is on the branches, okay, because if you think about looking at it sideways, you can see it looks like a tree with the branches coming up. On these branches, we always write the probability. Okay, so we know that the probability of throwing a head from a fair coin is 1/2, so I've written 1/2 on each of those branches, because obviously we're not changing the coin in between times. So that's what a probability tree looks like. If you've got any questions on that, ask me in the lesson, but we're going to have a look at this now. So we need to bear in mind that on each of these branches, because we're looking at 3 heads, so we're following this route here. Okay, so I want a head and another head and another head. Well, hopefully you'll remember from the work we did on independent defence, because we want a head and then another head and then another head. And if we've got ands in here, it means they're independent, so we're going to be multiplying the probabilities together. So the probability of a head equals the probability of the head times probability of a head times probability of a head, which is 1/2 times 1/2 times 1/2, which is 1/8.